Module 1. Why is testing necessary? Can you imagine if you went to the hospital for a life or death emergency and the system was giving the wrong information about you? Or imagine you went to the bank and all of a sudden all your money was gone. These are just some of the ways malfunctioning software could poorly impact our lives. So if you're still asking yourself, why is testing necessary? The answer is to reduce the risk of defective software, verification of the requirements, improve software quality, and validation of the needs. To understand quality, we need to really talk about quality management. As a product moves through the software development lifecycle, its quality is measured through quality management. Quality management you can think of as the overarching umbrella in the quality hierarchy. It's made up of both quality assurance and quality control. So, what is quality assurance? Quality assurance is normally centered around the appropriate procedures being followed. Following these standardized procedures and practices gives certainty that the fitting degree of quality will be accomplished. Think of it as your procedure that you're going to follow step by step. Quality control is more focused on the actual exercises of testing. These various exercises help accomplish the desired quality levels. So, if you're assembling a bike, you can think of quality assurance as similar to the instructions. And the quality control is similar to putting the bike together. So, the control is doing the exercise, actually putting it together. Assurance is the instructions to do so. Who is responsible for quality, you might ask? The answer is everyone. Software engineers, managers, all the stakeholders. Anyone involved in the software process is responsible for quality. So now that we understand quality management that is made up of both quality control and quality assurance, let's talk about the errors defect and failure is. It's best to walk through an example. So let's pretend we're building a software that will calculate the number of calories for your meal. The user story is, as a user, I can input my drink and the system will calculate the number of calories in that drink, so I know how many calories my drink contained. The user story would be created by the product owner and have the associated acceptance criteria. Fast forward a few sprints, and we have released our software to the public. We're starting to receive some customer complaints that when they enter their drink into the system, it is adding too many calories. We know that our system has a defect. The defect is most likely caused by an error made by our team. When the customers start adding multiple drinks into our system, the system eventually shuts down. This is known as a failure. So, error is a mistake made, a defect is a problem with the system, and a failure is when the system stops working. An important step when an incident like this happens is to understand the root cause, not to blame or point fingers, but to improve and get better from your mistake. For example, our defect for drinks adding too many calories could be because a person who created the user story did not understand the difference between calories and carbs. This caused the developer to use carbs instead of calories when adding the total, resulting in an incorrect calculation. Now that we know the root cause was a misconception about calories and carbs, we now can create an action plan to give training to our team so they learn about the difference and don't make this mistake in the future. So now that we know about errors, defects, and failures, let's just talk a little about the history of bugs. Bugs in software go way back. Let's look at 3 major known software bugs in history that have cost a lot of money for companies. So one bug was for an incorrect formula used for spacecraft source code. It cost $18.5 million. Another one was $125 million when NASA sent a climate orbiter because of an incorrect formula or calculation. And finally, the Knight's Error. When this miscalculation happened, it sent all kinds of trades out in the stock market that weren't meant to happen, causing a $440 million loss. I encourage you to go look up other bugs in history that have caused many software problems. It's a very interesting topic, and there's a lot out there.